So here I've got the device ID set to my robot. I'm setting the followers to 0, which is Mike's robot, and sending that. Then when I send forward, my robot receives the message and broadcasts it to Mike's. And we both move our robots forward. Similarly, we can move backwards and turn right. So the way this is implemented is that each robot has a list of followers, and it will broadcast any move commands it receives to those followers. So this is controlled using the web page, which is served up by the web server. And it contains a control where the user can enter a comma-separated list of followers, or empty if they don't want the robot to have any followers. And then when they press the Send Followers button, the code behind it will send a post message back to the web server with the list of followers and the device ID of the master robot. The web server receives that request and sends an MQTT topic for the master coffee bot appended with the command followers, and the command that it receives is the list of followers. So each robot is listening to that MQTT broker for topics that start with CoffeeBot and its device ID. So the master robot will receive this followers message and will clear and then set an array with this list of followers. This means that later, when the user clicks the forward button, the application will receive will extract the movement speed, and because it's forward, no rotation, and post this as a message back to the web server. The web server will receive this request and send this to the master robot with the payload of the forward and left desired motion. Then the master robot is listening to the same topic, and it receives this message ending with move, and it will process it and write it out to the serial port. That causes the master robot to move. But then, because the followers array has also been set, it then loops through each follower and sends the same payload, the same command, through to all of the other device IDs that it's been told that are going to be followers. And so those robots are listening for their device ID, and they also receive the move message with that payload, and then they execute the same action. And that's how the inter-robot communication can be set up and controlled using the web server. So the benefits of this architecture is that each component is separately scalable to meet the requirements of the system. For example, the web server, which is currently hosted by the robot for convenience, can be hosted on the cloud and scaled to meet the required number of users. The MQTT broker receives commands from all the robots, but it can also be scaled as required. And because it's on the web, it can be accessed from anywhere in the world, enabling any robot to be controlled by anyone from any device that they wish to use. The robots only subscribe to their own topics, and this means that they're not inundated with messages from other robots unnecessarily.